Hi friends, and welcome back in the data visualization series. So in this we'll examine the various visualization plots, and today main focus is our Choropleth by Plotly in Python. And you launch your Jupyter notebook, it would look like this, and what you do is go to your folder created of data analysis, and in that we will create one new Python 3 notebook. And I've already created one, so I open this untitled notebook, and you just rename it as the Choropleth Plotly. Okay, now what does this Choropleth mean? So it is one of the very interactive feature what Plotly offers, and Plotly is an open source library in Python which offers you data visualization. And you can see this plot, and it's self-explanatory that I wanted a plot which would plot all the countries, continents, and at the same time gives me information about the life expectancy. And when I hover over any of the countries, it just provides me with its name, life expectancy, and its code. Okay, so I can keep on modifying it with different codes. So we'll examine this, how do we plot this, and very interactive feature of Plotly, and we can use it in various data visualization and in different projects also. So let's start. So this data, from where would you get this data? So how do you do it is like there's a data in Plotly which it directly gets it from Gapminder. So this Gapminder is a data set wherein when you just write this command as px.data.gapminder and you download this data, you load this data, you will get something this 1704 rows and 8 columns. And you can see here that the features, or you can say the columns, consist of country, continent, year, life expectancy, population, its GDP per capita, and it's the ISO code, what the code of the country is, and its number. Okay, so this is how you load the data, and this already comes with this Plotly. And okay, I have to show you what all are the packages we have imported. So you just simply have to write import plotly.express as px. Okay, and this Plotly will do everything for us, just like pandas. So it has loaded this data. Then what we do is we, from this px dot I've stored this in a data frame, or you can say an object called data. So I'll show you, so that why do I do this? So that I don't have to write this again and again. Right now what I'm doing is I'm writing px.data.gapminder, then I'm asking it for the shape. So it is like 1704,8. It is giving me rows and columns. Then I ask for the information. So in info it will give me the null values, the zero, how many zero or null values are there, and we say that there are no null values, so the data is clean. And the data type, you can see that country, continent are object type, and rest are integer, and they're in the number format, right? Okay, next we come to what I have done is that in the value, and I have created an object, and I have got this value counts of this alpha, how many codes and this thing are there. So I get this value as like different codes with different codes and their values, like 12 and what are their values, right? Next I come to, and its length is 141. Okay, so like 141 countries codes are there. Next, what I do is I wanted to show you about one more thing before I show you seaborn and matplotlib plotting. See, you can do one thing, that you can store the data of px.data.gapminder in data, so that we don't have to write this entire code again and again, just like we did here. Again and again we were writing this thing. So I store it in an object called data, so that my work reduces of typing. So I have just stored it in data. Then I call this data.head, and I can see the first 5 entries by default: Afghanistan, Asia, and you can see the year, different years, 52, 57. Now I want to examine how many years are there, and what is the, like, how many continents is it referring to, because I can just see the data head and tail here, like the last 5 entries and the first 5 entries. So to make it more convenient, what I did is this last 5 entries, as you can see, is Zimbabwe in Africa, and you can see here, okay, like 2007 also we have the year. Now we come to this data. What I did is what I got the data count, the value counts of country. So I got data.get. This is a query I'm giving, and from the country you get the value counts, and it gives me that here these are all the countries, and again you can see that 142 countries, and the value counts is like 12. Okay, so that means 12 years, like years by year. So this is how it has been written. Then I got the value count of year. So again you can see that 142 like 2007, and if you go from 1952 to 2007, the data is being collected from like so many years. Okay, and you can also see that 12 years data is being collected here, and similarly that's why you can find in each country you have got these 12 entries of respective years. Okay, then we go on one more thing of getting the value count of continents. So how many continents are there? So you can see that there are 5 continents: Africa, Asia, Europe, Americas, and Oceania. Right? So African countries, you can see the value is 624, and Asia is 396, Europe, and so on. Now what I did is I wanted to show you the limitations of histogram, I can say matplotlib and seaborn. So what I did was, first of all, you have to import these two, like seaborn and matplotlib. So what you do is you go ahead and import these libraries. So they have been imported here. So I have imported seaborn as SNS and matplotlib as PLT. So you go down, and what you do is you plot this, the value count of the country and the histogram of the year. So we can see the distribution here, that distribution of the data in the of the year, like 50, and how many count is there in 1950, 1960, 70, and so on. But it is not yet very clear as to what it is trying to represent. So what I do is I also show you the count plot of the continents, how the value count, the count of Asia is like around less than 400. For Europe it is more than 300, and you can see match it here. It's 360 in Africa, it is like more than 600. In America it is more than 300. I think it is just 300, and in Oceania it is 24. So it's very less, right? So you can see the count plot of it. Next is what we can, now I'll tell you something about the describe feature, what we already do in data exploration, that the numerical part are being plotted here. So we get year, life expectancy, the population, and you can see the population, the number. It is, again, if you want to change this data, you need standardization of this, right? And then you've got GDP and you've got ISO number. Now we come to the interesting part of this, the main crux and essence of this video, and that is Plotly and its Choropleth, right? So what I did do is in one object you give a query. Okay, you've got this feature here dot query, and then give the year as 2007. What I want is I want the population of various countries, and I also want that it should give me its code, its name, and the population. Right? So how do I do it? I have given the figure of what does this figure do of in Plotly. It will plot the figure and will show me the figure. I have also uploaded one of the video of Plotly. Please go and see. I'll provide the link of it. And then what you do is px dot you write this Choropleth as it is, and then you give this data ds1 here. So it will go in the year 2011, and again according to the code, and what it will plot entire map of it. The color is population. Now this color can be experimented with, like life expectancy. You can give GDP here, so according to GDP you will get the data instead of population. Okay, simply by changing it, right? So hover name is country, hover name is this, the country which you can see, Canada, right? And the color continent scale, this is you write as it is, and this is called purple. Okay, and so you get the variation of purple here, and figure dot show will show you the plot, which is something like this. And when you hover over India, you will see that its code is IND and its population is like more than 1 million. In 2007 we are talking about, right? Okay, you over here in Algeria and you can find like the population something called 33.33 million. Brazil and Mexico, US, everything you will get, and whatever you want in Indonesia, Australia, New Zealand, right? Zimbabwe, South Africa, Zimbabwe. So, and also you're getting the code of it. Okay. Now I have told you that we can experiment with the color population. In the first figure which we have seen, this color is life expectancy, and this life expectancy, as you can see here, of different countries, and the sequence is plasma, so you can see it with different colors. Okay, so what I do is, again, the query is 2007. For the year 2007, the life expectancy of various countries in the continent, we see here that the country Canada has life expectancy as 80, more than 80, right? And if you want to see this Bolivia, it is more than 65. For India, let's see, it is 64, and for like Congo it is 46, so it's quite low, right? You scroll down in African countries and you see life expectancy here reduces, and you can infer many of the information from in here, like 42. Angola, Namibia 52. It is still healthcare requirements are needed, healthcare interventions are needed, but this data is of 2007. Maybe now, like it's to 2020, it must have improved, right? We don't have that data right now, so we can just say that in 2007 the case was this, right? So obviously it must have improved, right? So we need data for that. Okay, the Indonesia expectancy is 70. Okay, so this is how you can experiment with this. Next we come to something more interesting. Now we can just experiment in the next plots with the various queries. And now what I'm doing is I'm taking this life expectancy and the country again, and I've experimented with different color, that is sunset dark, and the sunset dark looks like something like this. And again you can see the same thing has been plotted but with different colors. Okay, so now change the variable and see how does it look like. So in this it is just continent, and I just wanted to show you the continent and then their code. If simply you just want the continent and code, the simplest graph is this, right? So, and you can see the continents, there's 5 continents being plotted with their country code. If you want hover name, not country, you can write something else, right? And if you want color not as continent, just mention here life expectancy or GDP or anything, and that would be plotted, right? Okay. Next thing I just wanted to show you is again the repetition of the same. Let's just write here, I think that's GDP. I just want to see the this thing, that it is GDP per capita. Okay, I'll just write here GDP, and it has to be same because it is case sensitive. Python is case sensitive, so I have to be cautious with this. So this GDP per capita, if I write here and I just plot it, okay, it's value error. What error is this? Okay, so if I just change it to like color as, why is it not giving me? Let me just see this experiment and life country. It is plotting this life life expectancy at birth, but hover name is country and locations. Okay, so it's just giving me the continent and it is giving me this thing, right? And but that is something different what we have got in the upper. As you can see, the codes which were more interactive, so something is wrong here. And what is that, right? So location is this alpha, it is giving me all the countries. As you can see, this political demarcation of the boundaries, and here as you can see that it is only giving me the entire continent, right? Okay, and it is just giving me the scale as sequential matter, but it is not plotted. It's saying location. If I write here as, you know, not continent, but if I write here simply as now let's see what happens. So it is again giving me this expectancy and Mali and everything. So instead of life expectancy, if I just give you over here, okay, fine. Let's again experiment with our GDP per capita, right? And it was yeah, right. Okay, let's see. Okay, so we got the GDP also plotted here, and we can see the GDP of India. We can see the GDP for the continent of Asia, for everything. And if you just want to change the GDP here, and you want to see, suppose for the year equals to, like, suppose for 2000, if you want to see this GDP, and for the year 2000 we have this GDP as for different countries. For Saudi Arabia, GDP stands something like this in dollars, and so on and so forth. You can go and experiment. So previously, if you give your locations as continents, it will not plot this political map, as you can see here, because this is dividing this alpha, this code of the various countries, and it is just demarcating the various boundaries of the countries, right? And for color, what is it's giving me the value, the column of GDP, right? What you want to see here, you can see population, GDP. You can see here one more thing what we've plotted, and that was life expectancy. Okay, similarly you can also go ahead with more experimentation of data where an unemployment rate is there. You can plot unemployment rate, give the year, but you have to have the data for that, right? So you can see the hover name of the country and this thing, right? So this is the feature of Plotly, that it gives you so good representation of country, wherein you just have to say that this Canada has GDP percentage as this thing, and so on and so forth. And when you know this country hover names, you can just you can simply write here continent also if you want to check it. And let's see what happens if you write here continent. Okay, and if you want to say continent, so you can say Americas, it's here. This is also, so you know that this is entire Americas, North America, South America, but not demarcated, so it's Americas. You can see your entire Africa. Now if you want to be more precise, what you can do is you can change this hover name to country. Okay, that's why we write here country to be more precise. You can keep experimenting and learning yourself so that you understand what it exactly is. So guys, go ahead and experiment with Plotly. It is very interactive graph, and you go in this built-in continuous scale, in this color scales, to explore more data, right? And this is what this scale is. I was using, like, you can use this greens, blues, orange, purples. What I have used was I used from here, right? Matter I used, okay, and then pinky, peach, any color of your choice you can use. You can use from these also, right? So these are various color patterns. It will be, that is how it will be plotted. Now if you want to see earth here, I can just show you from here. Like if I take here earth instead of matter, if I take here earth, let's see, and let's see. Okay, all right, you have to close this. So this is not in the sequence, and I think this is in different sequence. Okay, this is in different sequence. That why it has not worked, so I will not use it in sequence. Sequence I can use only this, so let's use the steel here. So in sequence, so you have to be cautious. I also got to know this now. So now the steel, and okay, so in teal color it could be plotted. Okay, right. So experiment with various colors and you will understand what works, what not. And please do like, subscribe and share if you like it, and tell me whether I can go ahead with more interactive data visualization libraries, its features. Go ahead with Plotly and explore its various features. And this is really interactive, and this is what the documentation string is, and you can just see various like the unemployment thing which I was talking about is this. So you have to get the data from here, so get the data, and it is in the GitHub, so you have to get this GitHub from this from this file from the GitHub. Okay, so you can go ahead and experiment with this, and there's a lot of data. Go experiment, visualize it and understand it, right, and become good analyst. Okay, so this is how you hone your skills. So that's all, and thanks for watching.